Hello and welcome. Thank you for joining us for Morehead at Home Skywatching. My name is Nick Eeks, and I'm an astronomy educator at the Morehead Planetarium and Science Center. Morehead is located on the campus of UNC Chapel Hill. We're a unit of UNC Chapel Hill, and we also serve the state of North Carolina through outreach programs like our mobile labs, skywatching, and the annual North Carolina Science Festival. Our mission is to increase public understanding of science, technology, and health, and we do that through programs and virtual offerings like this one. So we're really excited that you're here with us today. I know if you've been with us before, you're probably not used to me giving this introduction. Amy is out this week, but we have a special guest with us today, another Morehead educator. So we're really excited for our topic. Today, we're going to be talking all about the sun. So before we get into it, I'd like to introduce you to Solomon Starling. I'll pass it over to him to tell a little more about himself and a little more about what we're doing today. Take it away.
Hey everyone, like Nick said, my name is Solomon Starling and I'm an educator, an astronomy educator at Morehead Planetarium. And I'm very excited to be here filling in for Amy this week. Today normally we talk about kind of all of the stars that we see using Stellarium or in the Full Dome Theater, but today we're gonna kind of focus on our sun, right? And so we've got a poll question to get us started. But before we do, I want to mention that if you've got any questions for us, you can drop them in the Q&A. That's going to be at the bottom of your screen, not the chat, the Q&A, and we'll try to answer those toward the end. But our poll question for you all today to get us started is, how many stars are in our solar system? Do you think there's one star in our solar system? Do you think there's over 100 stars in our solar system? Do you think there's a billion, trillion, and 7 stars in our solar system? Or do you think there's infinite stars in our solar system?
See some good guesses rolling in. And if you've been with us before, you might have seen a question similar to this, but sometimes we like to retest your knowledge. So
yeah, we'll see. Yeah, if you've been joining along with the Morehead at Home crew, then you might know the answer, right?
Okay, we'll give you just another couple of seconds here. Okay.
All right, so we've got some good guesses here. And this question is a little bit tricky because there's actually only one star in our solar system. That's why we call it a solar system, just like we use solar panels or solar energy that comes from the sun. The sun is the only star in our solar system. So that is a little bit tricky. If we were to replace solar system with universe, that question would be a lot harder to answer, right? Although we do have some pretty good estimations that it would be about a billion trillion and 7 if you want to, add some humor to it, right? Or if you've seen our Magic Treehouse space mission show. So there are lots of stars in our solar system, but like we said, we're going to be focusing on the star of our solar system, which is the sun. And to do this, we're going to share some pictures of the sun with you. And so Nick is going to go ahead and do that.
Yeah, and just to let y'all know, we are going to be doing a little bit of interactive stuff with NASA Eyes in a little bit, but one of the biggest rules of science is safety first. So even though we're talking about the sun and showing you images of the sun, we have to let you know it is not safe to just go outside and look at the sun or to look at the sun through a regular telescope. You could damage your eyes. It's just something you never want to do. So all of the images we're showing you are from special telescopes that have solar filters that make it safe to look at the sun. So just keep that in mind. Our star is really special. It's really interesting, but it can also be dangerous. So just make sure not to go outside and look right at the sun. But Solomon, what is this kind of funny image that we're seeing now?
So this is actually the first photograph of the sun, and as far as I probably know, the first photograph of any star this close up. It was taken back in 1845, and you can see that the sun is really round. It's actually almost perfectly round, which is pretty cool. And you'll also notice, and I see we've already got a question about it, what are those spots? We'll get to those spots in a little bit. I'll go ahead and tell you they're called sunspots. Astronomers are not very creative when they are naming things, right? But first, I want to talk about what the sun is and what it's made of, because you've heard us call the sun a star. And well, what are stars made of? Stars are made up of gas, and our sun is mostly made up of hydrogen and helium. Those are two different gases. And the reason our sun is so bright is because it actually takes all of that hydrogen and mashes it together, because it's got so much mass and pressure and gravity that at its core, it squeezes those hydrogen atoms together to make helium. And this is called oh my goodness, nuclear fusion, because it's actually fusing two atoms together to make something new, right? Which is something that's really, really, really hard to do, but it makes a ton of energy. You can think of like two bowling balls, and if you were to roll them into each other, they would make a big noise. Well, that noise is sound energy, right? But instead of these balls rolling together to make noise, these hydrogen atoms are smashing into each other, and the energy they're making is not sound, it's mostly light and heat. And that's why the sun is so bright and hot, right? Now, it is really hot, but there are actually some cooler places on the sun also. And that's what we call the sunspots, right? And so sunspots are these places that are a little bit cooler than other areas on the sun, because since the sun has so much gas, it's got a lot of magnetic fields on it, right? And sometimes those magnetic fields actually get tangled up near the surface of the sun, and they kind of stay up there in the corona and on the photosphere, and they're much cooler. So those are the sunspots.
And here you can even see, hopefully it's showing up for you on your screen. We've been able to image these sunspots and how they change over time. So remember, the first image we showed you was the first picture of the sun from way back in the 1800s. Then I put up an image that's a more recent picture of our sun, taken from space telescopes. And this is something that's a lot more zoomed in. So hopefully you're at least getting a look at that, even if it's a little bit choppy. But Solomon did mention some of these different layers of the sun. So, of course, when you look at the sun, it's not going to have a big piece cut out of it like this, is it, Solomon?
No, no, definitely not. This is just to help us see the different parts of the sun if we were to dive into the sun. Now, Nick, you're not going to want to dive into the sun, right? It is really, really hot. But let's talk about some of these different layers of the sun. You can see that we've come a long way in being able to take different pictures of the sun, or even make different pictures of the sun, since all the way back in 1845. And we've learned by doing so all of these different layers of the sun. So I've mentioned two already, and that is the core of the sun. That's where all of that nuclear fusion happens, where those hydrogen atoms get smashed into and make helium atoms. That's where the light and heat comes from. And at the core, the sun is about 27 million degrees Fahrenheit. Really, really hot, right? So you don't want to get too close to the sun, okay? So we've talked about the core. That's where it kind of makes its energy. And we've also talked a little bit about the photosphere. Now, the sun is made of gas, so it doesn't really have anything close to a solid surface like we do here on Earth. But the closest thing to a surface that we do have, or can imagine the sun has, is the photosphere, that kind of outer layer where the sunspots occur. Now, there are some things around the photosphere called the corona. And there are some things happening on the corona, like you see these prominences. We can get some solar flares because the sun has so much energy that it's really almost kind of wild and unpredictable, and it shoots some stuff off occasionally. And so those are called either solar flares, or even bigger, they're called coronal mass ejections, right? All right.
So I have a question. The sun is the largest thing in our solar system, but is it the largest star out there?
It turns out that no, it's probably not the largest thing out there, right?
Yeah, so that can be really tricky because to us, The sun is huge. We're 93 million miles away from it here on the Earth, but we still see its light. I can see its light coming in my window right here, right now, and we feel its energy, and it affects our Earth. But that doesn't make it the largest star. It just looks like the largest one to us because we are way closer to it than any other star. So we've brought up an image here that always helps me to understand a little bit of the scale of things in our solar system. And I'm going to walk you through some of the steps here and explain what some of these things are. Because it turns out that our sun is pretty average. Even though it makes up about 99.9% of all of the mass in our solar system, all of the stuff, it's average in size compared to some others. So let us start in the top row. We'll start up here with number 1. You might see some familiar objects labeled Mercury, Mars, Venus, and Earth. Those are the inner planets of our solar system. They're a little bit out of order here for where they orbit around the sun, but size-wise, they're put in order from Mercury to Mars to Venus and Earth. And you notice Venus and Earth are about the same size. That's why they call Venus Earth's twin sister, but that gives us a reference for about how big we are. All right, so keep that in mind. As we move to number 2, now the largest object from number 1 is the smallest object on number 2. So here's our Earth, really, really tiny. And this is compared with the gas giant planets, Neptune, Uranus, Saturn, and Jupiter. You might have heard before that Jupiter is the king of the planets, the largest planet in our solar system. You could fit a lot of Earths inside of Jupiter. So mass-wise, about 1,000 Earths could fit inside Jupiter. It is enormous. But compared to a star, even really large planets like Jupiter are still very small. So let's move from number 2 down to number 3. Here's where the comparisons get into the territory of stars. Jupiter is this tiny little object here, and it's compared with a small dwarf star called Wolf 359, and then our sun. So this right here is our sun, but you notice right away, there is already something that's bigger than the sun. This big whitish blue star you see here is called Sirius. If you've been with our skywatching sessions before, you might have heard that Sirius is actually the brightest appearing star in our nighttime sky. At this time of the year, as we move through the spring and into the summer, we start to lose it a little bit, but it's still very, very bright in the sky. And it turns out that it's about twice the mass of the sun. So there's already one star that you might have seen before that is way larger than our sun. But even though it's the brightest one in our sky, turns out that there are still stars bigger than Sirius. So if we move to panel 4, you can see Sirius is tiny. And as we move up, there are stars even larger than Sirius. One of them, Arcturus, if you've been with us before, or if you've done some of your own sky watching, we know that we can use the Big Dipper to hop our way to Arcturus or arc our way to Arcturus. It's enormous. It is so much bigger than our sun that the sun would be a tiny, tiny speck on this large comparison. And as we move up and up and up, you might see some other familiar star names, Aldebaran, Antares, Betelgeuse. This is a supergiant here that a lot of folks think is about at the point in its lifetime to go supernova, which is exciting in a way. But even Betelgeuse, one of the largest ones that we can see, is small compared to other stars. So I like a comparison like this because when you start talking about the numbers of how big something like a star is, it can get very confusing. Like we pulled this number for how much gas is inside the sun, like mass, how much it weighs, and it's something like 2 octillion tons. So 2 times 10 to the 27th, which means a 10 with 27 zeros after it. That's too many zeros for me. Those are huge numbers. So I like to say things like, you know, the sun, you could fit 1 million Earths inside of it. 1 million is still a really big number, but that gives us a comparison. Or, you know, you could fit something like 100 Earths side by side across the sun. And those sorts of things give us a better comparison when we think of things that are so large. So I hope this helps you a little bit seeing maybe the difference between some planets and stars, but showing that, you know, our sun, is not the only star, but it's not the same as all the other stars either. So let's move forward. One really neat thing, you know, we could probably reference all of the stars that we see in the sky and compare and contrast them to the sun. But the neat thing about the sun is it's the star that we are able to study the most. Since it's the closest one to us, we are able to observe it safely and even get closer to it. So I've brought up an image of a really, really cool space probe that was launched in 2018. This is an artistic rendition. This isn't an actual picture, but this is what the probe looks like. And this might be what the sun looks like from the probe. It's called the Parker Solar Probe. So before Parker Solar Probe, there have been other things launched into space to help us study the sun. We've done observing from here on Earth, from orbit of Earth and things like that. But the goal of the Parker Solar Probe is to touch the sun. Now, that seems kind of scary. You don't want to get too close to the sun. You know, it's very, very hot, tens of thousands of degrees to millions of degrees. We don't want to melt. But this probe is specially built to be able to withstand that heat and get up close to the sun and help us get more accurate picture of what it's made of, where it came from, and how we know about it. So like I said, this was launched back in 2018. Here's a launch picture that I thought was pretty neat. And it successfully got into space, and it has a really, really neat path. It actually does orbital loops around Venus, which means it gets closer to the sun and swings back out near Venus and swings around again to be able to do multiple flybys of the sun and take scientific readings. So I'm going to talk a little bit more about the probe, but to do that, I'm actually going to go into a different program. So for 1 second, I'm going to stop the share and switch a couple things over. One unique thing about Parker is that it has this really thick heat shield. And we're going to try to look up close at that heat shield right now. So here we go. I have you switched over to NASA's Eyes on the Solar System. We've used this before in these sessions, but I totally encourage y'all that are watching to try this out yourself. It is a really fun program. It's free to download on your computer, and it allows us to kind of fly along with some of these spacecraft that are out there studying things in our solar system. So I started us off with an image of the sun. And this is one of the things I think this EYES program does really well, is give us a good detailed view of something like our star. Now, we don't have really good detailed views of all the stars like this. That's one of the reasons we want to study the sun even more, is that it can provide us with more knowledge about how the other stars work too. So we are way closer to the sun than you would really want to be. Remember, I said safety first. But what I want to help us find is this probe. So actually, to do it, I might have to move us around a little bit. I'm sorry if that motion bugs you at all, but you see here in EYES, it's labeled as the Parker Solar Probe. Let's get closer to it, because I want to talk to you about a couple of the parts and a couple of the goals of what this probe does. So this image, again, is not a live camera, but it is the live position of where the solar probe is. So at its closest approach to the sun, Parker is going to get about 3.5 million miles away from the sun, which is a very big distance, right? If you ran 3.5 million miles, your legs would feel like jelly. There's no way to do it because it's an immense distance. But compared to how far away the Earth is from the sun, that's actually a pretty small distance. Remember, we are about 93 million miles away from the sun. So relatively, this probe is able to get pretty close. And it's able to get close and still work because of this thick heat shield. So this is about 4.5 inches thick carbon composite that helps protect all the scientific instruments that are inside the spacecraft. So you can't see them all here, but you notice it has these long boom arms and all these sensors that come off of it. Parker is studying all sorts of things about our sun. It's studying the sun's magnetic field, like Solomon mentioned. The more that we understand the sun's magnetic field, the more we're going to be able to understand how the magnetic field affects us and how magnetic fields work around stars in general. It has sensors to help collect particles from the sun and study what we call the solar wind, which is how charged particles from the sun travel out into space. But I think one of the coolest things about it, and this is a fun fact that I learned, is that this heat shield is so effective that it's able to keep the instruments inside the probe at room temperature. So even though on the outside, this thing is heated to thousands and thousands of degrees, all the scientific instruments that are making the readings inside the probe are at room temperature. So I think it's a really neat lesson in what humans are able to do. We're able to put these instruments together to help us study something that's so far away and so dangerous to us, but still make it work. So the Parker Solar Probe's mission is going to extend all the way past 2025. So we're going to keep getting data from this thing and keep learning about our star, the sun. And if you already knew about Parker Solar Probe, one other neat thing about it is that humans, before it launched, were able to submit their name to travel along into space with the Parker Solar Probe. So there's a small chip on there that has everybody who signs up's name on it. And I know a lot of us at Morehead put our name on it. So I hope you did too, if this is something you're interested in. So all that being said, I know that's a ton of information about a really specific spacecraft. There are ways and safe ways for us to study our sun. So even though it's not safe for us to go outside and just look at it, there are cool techniques and cool information that we get from spacecraft like this one. So I know that there have been a fair amount of questions coming in for us, and the sun is complicated, but also we could talk about it forever. You know, we could talk about all sorts of details. I will tell you, for those of you who are interested in sky watching facts about the sun right now, the sunrise time today was 6 a.m. and it's going to set at 8:28 p.m. here in North Carolina, specifically Chapel Hill. So that's the time that the sun's going to be in the sky. But again, don't go out and look at it. We know it's our daytime star, and it's so bright that we can't see the light from the other stars in the daytime. So encourage y'all to go check out EYES yourself. We're going to transition in a moment to talking about your questions. So remember to use that Q&A function down there at the bottom if you'd like to ask us about any of the images you've seen today or any of the programs we're working with. But Solomon, we had one more question for our friends, right?
Yeah, so if you've been with us the last few sessions, this is the same poll question that we asked right before our Q&As. So that poll question is just how many people are watching on your screen? We're really curious to know kind of how many people are tuning in. And so we're just going to leave that up for a while, probably until the end. So just answer it whenever you can, right? Now, one thing before we get into our Q&As that I think, other than the fact that it's room temperature in the Parker Solar Probe, because that's incredible. But you probably noticed when you looked at the sun on NASA's EYES is that it's got a lot of different bright spots and dark spots. So we know that the sun changes a lot, and we're going to talk about it. It looks like we've got some questions about it, about these sunspots. So the sunspots are these cooler regions, but it also has these really hot regions also. There's sometimes, we call them facula or faculae, where it heats up because of those magnetic fields also. Because the magnetic fields get tangled up, and that's what causes it to cool down. But sometimes they break and burst in these huge eruptions of energy, and that makes the sun really bright in some spots also. So the sun is in some places really kind of dark and cool, and sometimes really hot and bright.
I will say, when we say dark and cool, not quite like dark and cool here on the Earth, just compared to the other parts of the sun around it. You're totally right, but it's not like cool enough for us to touch or anything.
Right. The coolest part of the sun is on the photosphere where we were talking about, and it's still 10,000 degrees Fahrenheit there. So it's still really, really, really hot. But you know, there are some cooler spots of the sun, I guess.
Yeah. And I think I probably didn't mention this, but we did have a question about it. Are there human beings on the Parker Solar Probe? No, there are no human beings on it. That's a good question, but it's a robotic probe. So it's actually controlled from here on Earth too. So that's one of the reasons why it can get safely close to something that is so hot. So very good question. Astronauts have never been to the sun. I don't think NASA intends to send astronauts close to the sun because we can study it without endangering people and making them sweat too much.
All right, so we've got a few questions here. And one, I believe, is about our star comparisons. When we're looking at the sun compared to other stars, a star that we've mentioned in some of our other Morehead at Home programs is Polaris, or the North Star. Well, how does Polaris size up to the sun? It turns out that Polaris is a little over 5 times bigger than our sun, and it's still it's a yellow supergiant, I believe. So it is bigger than our sun, but not as big as some of those stars in that star comparison that we saw.
I think that's a really good point, Solomon, because some stars that look really dim in our sky can still be really big and really bright. They're just extra far away. So that's a good reminder that, we have one perspective from here on Earth as we look out into space, but we have to be a little careful about just using how bright something appears to our eyes to judge how big the stars are. And Polaris is a good example of that, because in our sky, it's something like, the 49th brightest star. So that would make you think it's really dim and maybe even smaller than the sun, but that's just not the case. Great question.
Okay, some other questions we've got are, let's see here.
I see one here. Says, how far can the probe go? That's a great question. So it turns out that it's actually, with every loop, for lack of a better term, that it does around Venus back towards the sun, it's going to get a little closer and closer and closer to the sun, so that those readings it takes get more accurate. So it's something like 90 million miles away from the Earth at certain points, which is a huge distance. But its mission is going to extend, and it's going to get closer and closer. Good one.
Okay, well, what about some other stars? We've talked about their size, but what about their temperature? Are there stars that are as hot or hotter than our sun? Kim asks. And yes, there are stars that are much hotter than our sun. So our sun is a yellow star, but we've also got things like white stars and blue stars that are much, much hotter and burn a lot brighter than the other stars. Some other stars in our solar system, I'm making the same mistake. They are brighter than our sun, but we've also got stars that are dimmer and cooler than our sun also. We said that our sun is a pretty average star, so there are lots of red stars, especially red dwarf stars, that are much smaller than our sun, and I mean much smaller than our sun, and also not nearly as hot as our sun.
That's a really good question. That temperature is dependent on a lot of things. It's dependent on how old the star is, what type of gas is fusing inside of it. As stars get older, they change. Stars go through lifetimes. I know that's kind of hard for us to think about, because the star's lifetime is billions of years. But over time, they do change. So that's part of the point of doing some of the studies of our sun and other stars, is to see how our sun's going to change over time. I think it's really, really good for us to know.
Yeah, and our sun changes all the time, right? We've got a question about how many sunspots are on the sun. It's always changing. We do know that the sunspots tend to be on about an 11-year cycle. So partway through that cycle, we have more sunspots, and partway through, or at the beginning and end, we don't have as much. But it's impossible to tell, because it is always changing.
But we'll give it a good shot, at least. That's, it's hard to pinpoint an exact number, but we will keep looking and keep trying to get more accurate information about it. Now, I see lots of good questions about stars and their lifetimes and how they're created and how they change. I'm going to refrain from answering those right now, because we are going to do a future session that's all about lifetimes of a star. But I do see a question that's a little off topic, but still relevant, that I want to address before we move on. And that has to do with the SpaceX launch that happened on Saturday. So, still relevant. You still have to take things about stars into account when you launch space missions. But I will say that the SpaceX Crew Dragon on the Falcon 9 rocket successfully got our astronauts up to the International Space Station. So Bob Behnken and Doug Hurley, they've joined the current Expedition 63 crew on board station. And between the launch and the travel time of about 19 hours to get there and docking, everything was really smooth. And now they're completing their mission on space station. So we won't say that the SpaceX mission is done until the astronauts are back home. And we don't know exactly when that's going to be because there are a few things that kind of affect the duration of their time on the International Space Station. But it's really, really exciting and encouraging how successful the launch on Saturday was. There's so many parts that go into it. So many people have worked on this for about a decade and even longer, if you think about just the history of space flight. And sending a crewed mission from the United States back to the International Space Station is something that hasn't happened in about 9 years. So it's a lot of good milestones, but it also kind of shows us that there's more work to do and more excitement to come. So we're really, really excited that the astronauts got up there safely. And I'm sure they're excited to see some of their buddies on the space station as well. So we'll keep you posted on that mission. And if you have more specific questions about that, we're happy to talk about it. But if you haven't watched the launch, you can go online to the NASA website or SpaceX website and see a rebroadcast. It's cool for a number of reasons. Astronauts are flying on a rocket into space, but also the first stage of that rocket came back down to the surface of Earth, and it's reusable. And there are all these really neat scientific connections that we can make, with a launch like this one. So I know it's a little off topic, but we're excited about it, and I definitely wanted to address that question too. So looks like, even though y'all have so many good questions and I want to talk to you all day about them, that we are out of time. And I will say, if you want more content from Morehead Planetarium and Science Center, visit our website at www.moreheadplanetarium.org. You can check out the Morehead at Home page for all of our virtual offerings, whether it's 360 planetarium shows, sessions like this one, and much more. Follow us on social media, whether it's Twitter or Facebook or Instagram. Our Twitter's at Morehead Planet, Facebook and Instagram. You can search for Morehead Planetarium. And we have a YouTube channel that has virtual playlists. So if you missed something in this lesson or a past lesson that you'd like to go back and check out, you can watch those again. And these will be posted at a later date. So thank you, Solomon. I hope you had fun. He's going to be back with us on Thursday. And get ready. On Thursday, we're going to be talking all about black holes.
I am very excited for it.
All right, y'all have a great day.
See ya.